Okay, number 3, if the curve, so this one intersect the curve at points. So we see here there is 3 points where they intersect. Find the area between these two curves. So we see here we have to know the general form, how the shape of the graph. So we know that when we have x cubed, so here y is equal to x cubed, the graph is something like this. So when it is negative, so it's going down, something like this. Okay, so we see here, so how we see the shape of the graph, if we see from the highest power, so this one, the highest power is negative, so we know, so just y is equal to x square, so the graph would be something like this, smiling graph, and y is equal to negative x square, so it's something like this. So this is the shape of the graph. You just see this is a cubic function graph and the quadratic function graph. So we see here this one is -1, so something like this, and this one is something like this. Okay, so we see here intercept at negative. So we see 3 points, -1, 0, 0, 0, and find the area between these two curves, right? So we see here, so here just y is equal to -x minus x square. So this is the second graph, and this one is the first graph. So you can take out -x, right? So when you take out -x divided by -x is actually 1. So this one is plus x. So you can see that second graph, x is equal to 0 because -x is equal to 0. See here. And this one, 1 plus x is equal to 0. X is equal to -1. So we know, so we see here 0 and -1, so 0 and -1, so it's something like this. Okay, this is the first one. Okay, alright, so and then we have y is equal to -x cubed minus x square, so we can take out -x square, so we have same one, -x square. Here we have x and plus 1, so same. So x is equal to 0, x is equal to -1. So this is also the point of intersection for the graph. Okay, so we know this one and this one, so this might be something like this. So here, so we know the graph is something, so it's going up and it's going down again. So this one is going down again. So this one maybe intersection happens, which is this one is -1, 0, and this one is 0, 0, and this one is should be maybe 1, should be, because this one is the intersection, right, which is negative, which is 1 and -2. So there is 3 points of intersection. So we see here, so area between the two curves. So we see here, so we have 1 here, so we have 2 here, which is the first area and the second area. So we see here, to find the area we have to see from the axis. So we have to calculate from axis. We have to know which axis from. So if from the x-axis it should be dx, from the y-axis it should be dy. So the area is calculated from the axis. So you see here, my god, which one is the first graph? Okay, so this one is the first graph, and this, the black one, is the second one. So you see here, we are doing from the x-axis. So for area 1, you can see that from the x-axis, we have up, above, and below. So the up here, so this one, okay, so this one can be further divided, which is 1, which is 2, and which is 3, because we are calculating from the x-axis. So above x, below x, and this one is below x-axis. So area 1 This one above and below. So above the x-axis, we can see it is bounded from the graph. The pink graph, which is the first one, is this one. And then you see here, number 2 is bounded by only this one. This one is, okay, I should write it, which is, this is the y is equal to negative x cubed minus x squared. And this one is y is equal to negative x minus x squared. So for area 1, so we see this one is from negative 1 up to 0. So here from negative 1 up to 0. So the first one is actually bounded from axis to this graph, which is graph negative x minus x squared dx, right? This is the first one. So the second one, we know that under the graph, under the axis, when we do the integral, the value will become negative, but the area cannot be negative, so we have to put absolute or modulus function, so which is also negative 1 to 0. So this one, the graph from the x-axis is this graph, so this one is negative x cubed minus x squared dx. So we close back. So this is area 1. So just calculate this one first because we don't have enough space. So negative x is actually x power of 1. When we integrate, it will become negative x power of 2 divided by 2. So we add power with 1 and then we divide with the power. So this one negative. So x squared will become x cubed over 3. So we close back. This one is from negative 1 to 0. Okay. Plus, so don't forget we have modulus here. So x cubed, negative x cubed will become x power of 4 divided by 4. This one is negative. X squared will become x cubed over 3. This one is from negative 1 to 0. So we close with the modulus function. Okay. So now we can substitute x with 0. So this one will become 0. This one will become 0. So this one is actually 0. So minus, and then we substitute with negative 1. So when we substitute x with negative 1, so this one is negative 1 squared divided by 2 minus negative 1 cubed divided by 3. Okay, we close back. Also this one we have plus here. So again, when we substitute the equation with 0, x with 0, this one will become 0, this one will become 0, so it's actually 0. But you have to be very careful. Sometimes when we have sometimes the value won't become 0 when you have another, like you have another term outside here, like maybe plus 12 or something. So don't directly put 0, but you have to check term by term. Okay, now you have minus. So you now substitute with negative 1. So this one will be negative 1 power of 4. You see this one over 4. And this one is minus negative 1 power of 3 divided by 3. So just use calculator and you are supposed to get so I just write up here, sorry if you can see. So this one would be 0 minus negative 1 over 6. So this one is plus. So we have 0 here, 0 minus. So when you calculate this, you get negative 1 over 12. So you actually get 1 over 6 plus 1 over 12. So you get So you get 1 over 4. So we know that area 1. So area 1 is equal to 1 over 4 unit square. So this is area 1. So now we are going to calculate area 2. So we see here area 2. So we see here the intersection. So this graph is actually below here. So the intersection is actually under the x graph. So we see here from under the x graph. So we know when both is under the x axis. So we have to take the furthest minus the closest one. So we see here the furthest from the x-axis is this graph, which is the graph of So you see this one is a graph which is, okay, I deleted y is equal to negative x minus x squared. So above here is this graph. So when both graph is under the same axis, so we take the furthest one minus the closer one. So this one is actually from 0 to 1, because this is 1, negative 2. So from 0 to 1, so we can just directly minus y2 minus y1. So this one is dx. So 0 to 1. So our y2 is the furthest one. The furthest one is this one, which is x cubed minus x squared. So negative x cubed minus x squared. So minus y1. So our y1, the closer one, is this one. Which is equal to 0, 1. So the furthest one, the furthest from the x-axis is this one, which is negative. Okay, this one is the graph of this one, negative x minus x squared, right? Minus. So y1 is the closer one. The closer one to the axis is this one, which is the x cube graph. This is the cubic graph, dx. Alright. So this is 0, 1. So this one would be negative x minus x squared. So negative and negative become positive x cubed. Negative and negative become positive x squared dx. So we see here negative x squared and x squared can be eliminated. So we get 0, 1. So negative x plus x cubed dx. So now you can integrate. So negative x is actually power of 1. So you add power with 1, you get 1 plus 1 is 2 divided with power. Plus, so x3 will become x4 divided by 4. So you close back, and this is from 0 to 1. So you substitute with 1 first. So this one, when you substitute with 1, negative, so 1 square over 2. Plus, so this one would be x4 is 1, 4 over 4. Minus, so when we substitute with 0, you will get 0. So this one, which is equal to, so this one would be negative half, and this one would be 1 over 4. So you see here we get negative 1 over 4. So forget this one is under the x-axis. So when we do integration, we will get a negative value because it is under the axis. So what we should do is that, sorry, for the A2 just now, we should put modulus. So put modulus. So you will get 1 over 4 unit square. So this one is equal to 1 over 4 unit square. So the area is actually area 1 plus area 2. So here we get 1 over 4 plus 1 over 4. We are supposed to get 1 over 2 unit square. So we see here, so I just want to show you for the area 2. You see here, this is under the axis, right? So why we minus the furthest minus the closest is that when we find the area of the furthest, we will get everything from the x-axis to that graph. So we get this area. But then we don't want the area. But we don't want the area here. This is not the intersection of the graph. So this area is in between the axis and the graph closer to the axis. So that's why you just have to minus the furthest minus the closest to the graph. So you can directly minus y2 minus y1 dx. But then if you want to do 1 by 1, right, you want to do y2 dx plus minus y1 dx, you will still get the same answer like when you combine. Why? Because this one is from this one is 0 to 1, this one is 0 to 1, so it's actually same, so you can just directly combine 0 to 1. Okay. So B, given the curve y is equal to x squared minus 4x and y is equal to 2x minus x squared intersect at 2 points, find the area of the region between the two curves. So like in A, you have to know how the graph looks like. So you can see whether you want to plus or minus when you do calculation. So this one is here. So y is equal to x squared minus 4x, which is equal, we find the intersection first. So the x intersect first, so this one x minus 4. So when y is equal to 0, x is equal to 0 and 4. So this is for the first graph, 0 and 4. And you can see the x squared is positive, so it's something like this, where it intersect 0 and 4. So for the second one, y is equal to, so we see here 2x minus x squared, right? So you can take x, so this one will be 2 minus x. When this one is 0, x, 2 minus x is equal to 0. And this one, 2 minus x is equal to 0. So x is equal to 2. But you see here, the highest power is negative, so it's something like this. So this one is 0 to 2. So the graph looks something like this. So you can see, you can like draw to see how the graph look like. So 0 to 4, 0 to 2, so the graph start from 0. So we have 2 here and we have 4 here. So we know this one is from 0 to 4. So the midpoint must be 2. So something like this, 0 and 4. So I just write this one is y1, which is equal to, this one is x squared minus 4x. Okay, and then for the second one, 0 to 2. So we see here is intercept at 2, so it must be something, okay, so the midpoint, so something like this. Okay, so we can see this is how the graph look like. So this one is y is equal to 2x minus x squared. So the intersection is this. So we have to know which points they intersect. So this one is obviously 2, 0, but we have to point what is this at x-axis. Okay, so we can do simultaneous equation. So here we have y is equal to x squared minus 4x. So here y is equal to, so I want to rearrange it so that x squared will be in front. So this one will be negative x squared and I have plus 2x. So I want to eliminate y, simultaneous equation. So I minus x squared minus negative x squared, I get 2x squared. Negative 4 minus 2, we get negative 6. This one will become 0. So we see here, so where is space? Okay, here. So 2x squared minus 6x is equal to 0. So I can take out 2x, right? So when I take out 2x, I am left with x minus 3 is equal to 0. So 2x is equal to 0, x is equal to 0, and this one, x minus 3 is equal to 0, x is equal to 3. So we know that this one is, the point here is 3. We don't know the y, but actually the y does not important because we are doing area from the x-axis. Okay, but if you want to find, you can just substitute the value of 3. So here when you just take any, you have to take this one. When x is equal to 3, y is equal to 3 squared minus 4, 3. So I get 3 squared is 9, 9 minus 12 is actually negative 3. So this point is actually 3, negative 3. So we see here the area. So from 0 to 2, so this one is area 1, this is area 2, and this is area 3. So we see here for area 1, Because why we separate area 1 and area 2? Because this one is above x-axis. We know above the x-axis the value will become positive. And we know that number 1, area is from the x-axis directly to 2x minus x squared. So for area 1, so it is from 0 to 2. You see here, this one is 0 to 2, and the graph is 2x minus x squared. So when we integrate, so 2x, 2 we just write the constant, x is actually x power of 1, it will become x power of 2 divided by 2, so minus this one will become x cubed over 3. So we close back, this one is 0, 2. So here, so you have x squared minus x cubed. So first we substitute with 2, so 2 square minus this one will be 2 cubed over 3. So the first one is done, minus, but we see here when we substitute x with 0, this one will become 0, this one will become 0, so actually minus 0. So here we have 4 minus 2 cubed is 8 over 3, so we get 4 over 3. So just write it here first. Okay, where? So here area 1 is equal to 4 over 3 unit square. Okay, now for area 2, you see here it is under the x-axis. So we know that under the x-axis, when you calculate, because now we are doing with respect to x-axis, right? Y dx. So from the x-axis, so under the x-axis is negative value when we do integration. So when we calculate, we have to put modulus. Or after we get the value, the negative, we have to turn it to negative, to positive, because area cannot be negative. Okay, so this one, you see here 0 to 2. But this one, the graph that is attached to the x-axis is the blue one. The blue one is x squared minus 4x dx. See here, x squared minus 4x. So this one, when you integrate, so just put the modulus one first. So x squared will become x cubed over 3 minus 4x squared over 2. Because x will become, x is actually power 1, x2 over 2, 0 to 2. So this one you can cut 4 and 2. So you have here modulus, so x3 over 3 minus x 2x squared, 0 to 2. So first you substitute x with 2. So here you have 2 cubed over 3 minus 2, x is 2 square, right? So this is the first one, and then you minus, you substitute x with 0. So we know that when we substitute this one with 0, we get 0. We substitute this one with 0, we get 0. So it's actually 0. So this one is modulus. So 2 power of 3 is 8 over 3 minus 2 times 4 is 8. Right, so minus 0 is just that one. So here we get negative 16 over 3. So here you get 16 over 3 unit square. So area 2 is actually 16 over 3 unit square. So here area T is actually equal to, so we see here area T. So when we have, so from the same gap 2 to 3, we have two graphs. So it's actually, so this one is from 2 to 3, right? 2 to 3. So the furthest minus the closest. The furthest one is the blue one. So you see the blue one is the furthest from the x-axis, paling jauh. So here it is x squared minus 4x. So minus, so the closer one is the pink one. So the pink one is 2x minus x squared. So we see here the graph is under the x-axis. So you are supposed to put modulus because the value will become negative. So here, so this one 2 to 3, so x squared minus 4x. So this one is minus 2x. Negative and negative become positive x squared dx. is equal to, so x square and x square we get this one 2 to 3, 2x square, negative 4 and negative 2 we get negative 6x. Okay. Which is equal to, so 2x square, when we integrate we get 2x cubed over 3. So minus this one is 6x, so 6x will become x square over 2. So this one is from 2 to 3. So this one is, we get 2 over 3x cubed. So this one and this one can be cut off to become 3 minus 3x square, 2 to 3. Which is equal to, so first you substitute with 3, so just write it here. So 2 over 3x cubed minus 3x square, 2 to 3. So when we substitute 3, jangan. Which is equal to, when we substitute with 3, so here we get 2 over 3, 3 cubed minus 3, 3 square. So we see x substitute with 3. Okay, minus, so we have modulus here. X substitute with 2. So here we have 2 over 3, 2 cubed minus 3, 2 square. Modulus, so here we get modulus negative 9 minus negative 20 over 3. So here we get negative 7 over 3, so which is equal to 7 over 3 unit square. So now this is area 3. So we know that area intersect is equal to A1 plus A2 plus A3, which is equal to 4 over 3 plus 16 over 3 plus 7 over 3. So here we get, which is equal to 9 unit square.